Example 2. Two possible solutions. We're going to evaluate the integral of the square root of 2x plus 1 dx. Okay, so let's do the first solution here. So we have the integral of the square root of 2x plus 1 dx. Okay, so what we're going to do here is we're first going to let u equal what's under the radical, which is 2x plus 1. Okay, and then we're going to take the derivative of both sides. So we have the derivative of u, the derivative of 2x is 2, and that's 2 dx. Okay, now if we take a look at the problem here, we notice that it's just dx that we want. So we need to isolate the dx over here by dividing both sides by 2. So therefore, 1/2 du is going to equal dx. Okay, and we know that u is going to equal 2x plus 1. Okay, so now what we can do is we can rewrite this now as the integral of, well, we know that 2x plus 1 is u, and we know that dx is going to be 1/2 du. Okay, now we can factor out the constant, which is 1/2. So we have 1/2 times the integral of the square root of u, which is the same thing as u to the 1/2 du. And now we need to find the antiderivative of u to the 1/2. Well, we know that the derivative of u to the 1/2, so we got 1/2 times, well, u to the 1/2, the antiderivative is going to be 2/3 times u to the 3/2 plus c. And so now if we simplify a little further, we can see that the 2 become 1, so we have 1/3 u to the 3/2 plus c, and then we need to replace u with what we defined it to be up here, which is 2x plus 1. So it's going to be 1/3 times 2x plus 1 to the 3/2 plus c. Okay, so that is one way of solving this problem. Okay, now let's try another one here. Okay, so again, we have the integral, which is the square root of 2x plus 1 dx. Okay, now let's say we decide instead of u equaling 2x plus 1, we're going to let u equal the square root of 2x plus 1. Okay, so that means when we want to find the derivative of each side, well, that's going to be 1 over the square root of 2x plus 1 dx. Okay, and if we want to solve for dx, then what that means is we're going to get the square root of 2x plus 1 times du, which is equal to dx, because we want to make sure that we're solving for dx. And then what do we know that u equals? Well, it's going to equal square root of 2x plus 1. So that's going to be u du, which is equal to dx. Okay? So, what do we know here? Well, we know that this square root of 2x plus 1 is equal to u. So we know that that's u times, what does dx equal? Well, dx equals u du. So that's going to be times u du. Okay, and then what this gives us is u times u, which is u squared du. Okay, and now we can find the antiderivative. And so the antiderivative is going to be 1/3 u cubed plus c. Okay, so now what we can do is we're going to replace what u represents in our problem. So we have 1/3, okay, and so we're going to cube this plus c. Now, what did u equal at the beginning? Well, u is equal to the square root of 2x plus 1. And so therefore, this becomes 1/3 times, this becomes parentheses 2x plus 1 to the 1/2 raised to the 3rd power plus c. And if we want to multiply that power of 3 times 1/2, then we're going to get the following. 1/3 times 2x plus 1 to the 3/2 plus c, which is what we get in step 6 in the other one to the left. So therefore, this is another solution. Okay? So here in the first one, we let u equal what was underneath the radical sign, which is 2x plus 1. Over here, we let u equal square root of 2x plus 1, but we still end up with the same result.